With all the complexities of the EU, national and international legislation, funding and advocacy, running a successful company in Europe is complicated. There's an easy way to make sure your company's concerns are being heard. Become a member of UNIFE. Get access, influence, and visibility where it counts. Starting with a direct line to the decision makers creating regulations that shape our industry's future. UNIFE gives you the intel you need to access many funding, research, and partnership opportunities available. We provide you with all the latest information about the rail industry. UNIFE has dozens of committees and working groups to help guide our members through our advocacy strategy and share best practices around a wide range of topics. You'll also get fantastic speaking, networking, and sponsorship opportunities with key partners, potential clients, and decision makers in our sector. With over 100 members, we fight for more business opportunities for European rail manufacturing companies worldwide. Join us at UNIFE.
When you're here, you'll discover this. You'll relish in this. This.
Antonella? Are you connected?
Yeah. Here I am.
Fiona, just say something.
Okay, can you hear me?
We'll be starting in about 3 minutes.
Okay, but can you hear me now? Yes, we do. Oh, okay.
Ladies and gentlemen, the ICT conferences are about to start again.
When you're here,
Please
you'll
take
discover
your
this.
seats.
You'll relish in this, and this too. And you'll be amazed by this. This artwork will still be here. These landmarks too. You'll get around like them. Or maybe like them. You'll vibe with people like this. And we'll share all that. There you go. When you get here, we'll be waiting. Toulouse à tout.
Il ne manque que vous.
So, everybody is seated? Okay, fine. So, we will restart with this new panel regarding digitalization. So, as we discussed before, digitalization is a good way to gain productivity, to decrease cost, and to increase the use of assets. We have learned that the Commission is pushing for digitalization for railway, and in their plan, the National Recovery Plans, they try to ensure that at least 20% of this plan is dedicated to digitalization. So we will start with the presentation of Antonella Trombetta regarding ATO, Automatic Train Operation. Antonella, the floor is yours.
Yes, thanks. I hope you can all hear me. Good afternoon, everybody, ladies and gentlemen. I'm Antonella Trombetta. As you can see, I'm the head of Business Management Office and Industry Affairs for the EMEA, European, Middle East and Africa of Hitachi Rail STS, and I'm also the IP2 coordinator inside Shift2Rail. And it is mainly the activity that I'm doing in the last period, and this is the reason why I'm here at this beautiful workshop. Next, please. Okay, here you can see more or less the essence of the innovation program 2 of Shift2Rail, that is the Advanced Traffic Management and Control System. We have we are studying, because this program will end in 2023, the next generation of the communication system. In fact, in the last years, the communication technology has had a big improvement, and this improvement allows new features to the signaling part. The impact of application of the next communication system opens a deep study on the cybersecurity. I have also heard a lot of sentences about cybersecurity in the previous presentation, and this cybersecurity needs to be applied in all the context of the signaling system, of course. And a strong application of the new communication system is especially in the smart wayside object controller via radio, and with a strong reduction of the cables along the line. We have in the IP2 framework, we have also moving block and train integrity that are a new concept of driving. Like when you are in your car, you drive according to the speed of the car in front of you. And this is a new concept in railway. There is also the virtual coupling, another very, let me say, innovative idea inside the railways, that is like to couple two trains, of course virtually, in a kind of a platooning. It means that the first train drives not only itself, but also the following one. Then we have also the new train management system for a more complete and efficient management of the traffic. Then there are two topics that are formal methods and zero test on site, sorry, that help the train operation. Then we can move, thanks, for the next slide. We have here the, how can I say, the main goals of the IP2. That means that are under the strategic guidance of the European Commission. that would like to have, of course, the overall sector commitment in terms of a functional architecture, requirements, specification, KPIs and demos, a strong synchronization with the European Railway Agency that allow Shift to Rail in the collaboration of the project, reviewing the specification as ERTMS system authority, and the integration of the specification in the TSI. And a coordinated deployment with the investment for the migration. Okay, next. Now, why ATO? Why we are speaking about ATO? We can have benefit at every levels. We can have benefit at the train levels, reducing the operating cost with an energy gain typically up to 15% in the intercity and 45% on regional. We can have benefits at the network level because there is no provision for driver reaction time, and we have the reduction of dispersion of driving styles that will reduce the margin in timetable from 33 or 25% down to 15%. And we have also the reduction of the operational headway. We have also benefit at quality level because with the ATO it's easier to achieve punctuality and journey time and also increase the impression of comfort. The following two slides, we can see an example of energy saving in intercity trains and in local trains as well. As you can see, the different behavior of the drivers in the same journey can have, how can I say, can have a potential consumption of up to 15% in the intercity. This due only to the different behavior of the drivers. Next, please. In the following, you can see that the following slide, you can see that for the region in which there are more stops, this potential consumption is up to 42%. So I think that applying the ATO can give a real answer also to the energy saving. That is something especially requested in this period. Okay, next please. Just give information about ATO. ATO has the ATO is a mode of driving the trains. That have, of course, you can apply the ATO only if you have an ATP, so an automatic train protection. We can have different grades of automation, and this is more or less describe everything. We have a grade of automation 1, that means that the drivers drives the train, and the GA2, when the ATO helps the driver to do some function as driving and stopping trains, and for the door management, and in case of disruption event that the drivers take the leadership. In GA3, we have the ATO that drives the train without the driver, but we have still a driver on board that can manage some specific situation, especially in disruption events. And the GA4, when the train is fully managed by the ATO. Next, please. Okay. Here you can see the starting point from which we, as a Shift to Rail, starting our activities. Of course, the beginning was what was developed, what was studied in the 10T and in GTC. And the aim of Shift to Rail is to have the product development at the GA2, so at a grade of automation 2 level, with the test in test benches, but also in pilot line. Then after this, inside the shift to rail again, there is the complete process for the GAOA4, so from the feasibility study to the pilot line demonstrator. Please go on, no problem. Then here you can see, just to give a snapshot about, this is the architecture of the Grid of Automation 1. So you can see that there is only one standard interface between RBC and onboard, and all the management is done by the driver. So it's the driver that drives the train. While in the next slide, please, you can see the GOA2, sorry, next slide. I don't know if there is, okay, some delay in my presentation. In GOA2, you can see the standard interface between the ATO trackside and the ATO onboard, and between the ATO onboard and the onboard AVC. The definition of the ATO behavior as the interfaces are all described in the interoperable specification. And this is mainly the activity that we did inside the shift to rail. Next slide, please. Okay. Okay. Here are described all the grid and available work done inside the shift to rail. Of course, something was already present thanks to the 10T development, the 10T development, and as you can see, there are a lot of modification in the existing subset, and also new subset that manage the interface, the standard interface that we saw before. The good thing is that all this specification will be finished, is finished, and ERA endorsed them, and they will be published in the next TSI in 2022. Okay, these are some slides. Then the next slides are more or less some description of what we did in terms of test inside the Shift to Rail program. As already anticipated, the Shift to Rail has the aim to have test benches as a test pilot. In this case, we are speaking about test benches, one in Germany and the other one in Belgium. The tests were performed at the end of 2018, beginning 2019, and more or less 21 scenarios were performed, trying to cover the main functionalities. As you can see from the logo of the companies, there are many companies that participate and perform tests together in a collaborative way. Yes. Everyone more or less had its own product that was interfaced and had that also demonstrated the interoperability. Next, please. Here there is the description of the pilot test of GA2. It was not only for passengers, but also for the freight. As you can see, there were two different pilots, one in UK and the other one in Switzerland. The one in UK was more related to the passengers, while the one in Switzerland was related to the freight one. Of course, the target was the interoperability, the operation, and the freight application one side and the passenger application on the other side. I would like to stress this concept about the test, because we performed this test in 2020. So exactly in the middle of the not in the middle, but at the beginning of the COVID-19 pandemic. So it was not easy to perform that, to go through to states. It was not easy to install all the equipment on site, but the result was very good, and it also helped the fact that we are confident about the the new TSI that will have a specification well tested on site. Okay, next please. Now we are working on the ATO GA4 architecture, and it's, how can I say, of course there are a lot of specification, but in this case it's very important, considering that the GA4 means that only the train, the ATO will drive the train. The ATO needs to replicate the driver behavior and function related especially to the perception and incident prevent. So it is very important how to manage the train in this situation, and this is the challenge that we have now in this moment. If you go to the next slide, please, you can see the time schedule. The aim, of course, is to reach the development of the product of the ATO GA4, and also to have tests in test benches and also in the pilot line. The aim is to finish the development next year, 2022, and the demonstration before test benches and then in the pilot line in 2023. Next, please. I think that now we are at the end. This is the conclusion. We are proud that the interoperability has been demonstrated. The pilot test, even if in a very difficult period, demonstrated that the deployment of GA2 on existing train is okay. Then the specifications are interoperable, and the ATO over ATCS will be part for sure of the TSI 2022. We also achieved the objective to demonstrate that we increase the performance, we decrease the energy consumption, and also we have a better comfort. We are working on the GA3 and 4, and the involvement of the agency will start in 2022. And as I said, we will have as next step the TSI in 2022 for the GA2 and the pilot test of the GA4 in 2023. Thanks a lot. I hope that it was clear enough.
Thank you very much, Antonella, for this clear explanation of the different level at GEO 1, 2, 3, 4 and the status on the different development in Shift to Rail. So thank you, and we can go to the next presentation, a result from Shift to Rail Connecta with Carsten Pfeiffer from Alstom. So welcome.
This is not the correct presentation. Number 19. Yeah. So I'm Carsten Pfeffer. I'm working for Alstom, formerly working for Bombardier. And I've participated in the Shift to Rail Connector project. And I want to tell you something about one of the results, which is the specification of the simulation and virtualization framework. First, some things on past and present testing. It is testing on real trains, and this is quite expensive. It is sometimes quite dangerous. Why? Because you need a train, you need a track, you need an operator, so it's quite time consuming. You have high power stuff you need. You have quite high speeds. Sometimes you have noise and so on. And it's sometimes quite critical. For example, if the brakes do not function correctly, then it's not fun to test it. Also, testing on real trains is not complete and not deterministic. For example, you cannot test everything like broken cabling or something, or for example broken or not working brakes, and you cannot reproduce tests correctly with the same preconditions, with the same timing, for example. And also testing on real trains is getting more complex due to the huge amount of software that is on the trains currently. Yeah. And of course, on trains also you have a limited support for automation, for continuous integration and testing. One goal of Connector was then to get some further steps to the virtual testing and virtual homologation, and the result is a full specification of the simulation and virtualization framework, which is then supporting the test automation on all levels, which is supporting tests in laboratory environments or also in software in the loop environments. And this is then providing left shift of all the tests, providing early feedback to software developers and so on, and so saving time, saving costs and so on. Yeah, the first thing that is defined is to specify a simulation execution environment with all the communication protocols we need to combine all these components. We have some tools based on the PC for management, for configuration, and we also have a hardware in the loop interface, which we need to again trigger or stimulate hardware devices. The first is the software tool set. This is planned to run on the PC, on the tester's PC. It contains a configuration tool which is needed for the network parameters, for the telegrams, data signals, and so on. We have a monitoring signal which is defining which part of the data we want to monitor, we want to measure, like signal values, like the state of the simulations, and so on. And we have a test automation tool which is used to evaluate tests, to run tests, and also to maybe replan tests that have failed in a previous stage. Then the simulation host is part of the simulation framework. This is handling the basic communication levels. This means that it provides some high-level data signals later for the simulations, for example. It has management signals for powering simulated devices and so on. And it also supports fault injection into communication layers, for example. It is then also available to have some antivirus and electromechanical simulations running on that simulation host. The simulation host will also control the hardware in the loop interfaces, so the physical interface to real devices. And it should also communicate to other instances of the simulation host for distributed testing or for co-simulation stuff. Then let's talk about the device simulations. The first thing we have is end-device simulations. It's a logical scope, a simulation of an end device communicating over a network. It's a quite simple API. We have a setup and a cleanup method. We have a start, stop, reset methods. We have a read inputs, write outputs, and some processing stuff. And the interface to all the rest, to the communication and also to other simulations, is a signal-based interface. So it's a kind of high-level interface on data signal level. So such a simulation doesn't need to handle communication layers like safety layer version 2, for example. So it's more easy to implement and to maintain those simulations. And we have, sorry, one back again. And we have a dynamic approach here, so that we have the possibility to exchange a real system by a simulation at runtime without a need of reconfiguring all that stuff. The hardware in the loop is needed since if you look at the upper image here, we have an electromechanical environment to the real end devices, like speed sensors providing just an electrical signal, like temperature sensors using the outside temperature, for example, or pressure sensors or whatever. And if you want to replace that by a simulation, then you of course need a way to still trigger the inputs of those still real devices. And for this we have the hardware-in-the-loop interface that can then provide electrical stimulating signals to the real devices of the SUT. The next thing is the co-simulation and distributed test setup. So co-simulation means we designed one simulation host for one consist. So if we have a multi-consist setup, then we need several instances of the simulation host, which need to be synchronized, for example, for the train speed. Simulation distribution means that it should be possible to distribute the test setup to different test sites, for example, for load balancing, or for example, for providing specific test means like a climatic chamber for different, for specific parts of the test setup, and some other things that can be located in the developer of the TCMS, for example. The software in the loop is more or less the fully virtualized environment then running on the developer's PC. So we have support of running a complete train on the developer's PC, which also enables then for cloud testing, also for continuous integration, continuous testing, fully automated. We have synchronized the components here with a simulated real-time environment. This also then supporting slowing down the complete system, and also for speeding up. Slowing down is required, for example, for debugging. If you have a developer that is stopping one of his simulated applications, then of course all the rest of the simulation should also stop. And speeding up is quite interesting for long-lasting tests like preconditioning, for example. And the end-device emulation is then kind of emulation of the real environment for the to be able to run the complete real software on such an emulated device, which is then a step towards a virtual homologation, so that we can use those results for homologation process. Yeah, thank you for the audience.
Thank you for the presentation and the way to improve and to speed up homologation. So the next presentation is on artificial intelligence, Stefan Gribel. So Stefan, are you online?
Yes, can you see and hear me?
Hello, yes, we see you. Perfect.
Hello.
The floor is yours.
Thanks a lot, and thanks to everybody for having me at this ICT for Railways. I have to admit that I'm very honored to be part of that today, because for years I have been watching the ever-growing importance of this meeting of the ICT, and also in TC9X we very intensively talked about this. So thanks a lot for having me today, and that I can participate with my scarce knowledge about artificial intelligence and standardization, which I want to talk to you about today. This is based on a report also we had at the Senelec Signaling Committee, SC9XA, together with the UK chairman Roger Short. So next slide, please. Okay, there's a little delay. So I'm the, besides my normal work at Siemens Mobility as a RAMS engineer, RAMS expert, I'm the Senelec chairman for the railway signaling. I'm working in Germany for the Siemens Mobility company for 20 years now. I'm in Siemens internally. I'm the chairman of the Siemens expert group on artificial intelligence and safety. And I'm also the German chairman for the railway signaling. So I have to admit that I can't deny some responsibility of what is going on in the standardization committees when it comes to, for example, DKE, the German committee, and the European Signaling Committee. Next slide, please. The topic of today, you can click 3 times, then we have the whole display. I don't want to make it too complicated. So the whole abstract would be already, so the management summary would be that when it comes to artificial intelligence, however it is defined, we will come to that later, also including machine learning, there are fascinating applications right now in the field also of railways, surely enough, mainly focused on diagnosis of preventive maintenance on RAM aspects. And there are some first timid steps into also certification when it comes to safety. And that I like to focus a little bit on today, because my second message would be that there are, for electronic systems, I only can speak for electronic systems, I'm not a mechanical guy. So from railway signaling point of view, we have very elaborate safety standards that also cover software aspects. And surely enough, they will remain in place and be, let's say, the bottleneck, even for algorithms that deal with artificial intelligence whenever safety is involved. That would be my main message. Yet we have to recognize that the existing standards might not cover each and every new aspect that comes with the application of machine learning. The tricky thing is that, as always, some hard problems when it comes to artificial intelligence and machine learning remain to be solved, but that's what research is for, isn't it? Next slide, please. That's just a marketing slide about the various gazillions application fields you could use artificial intelligence and machine learning in. So we can skip that, because I was also told to be very brief and succinct. You might have noticed that when it comes to artificial intelligence, it features on, let's say, every second slide wherever you look at. So left, right, and center, we have these artificial intelligence themes. And I have to out myself as a mathematician. So I was very interested in what's behind the slides and what are the real algorithms mathematically about. And that's very, very fascinating, but I hope I don't have to make marketing for that. What I like to come across, to bring across with this slide is that especially machine learning is part of artificial intelligence. Artificial intelligence in general, there are a lot of definitions, but seems to talk about the ability of machines to simulate human behavior and to mimic cognitive functions. That seem to be also characteristic of humans. And there are also logic analysis, there are expert systems involved, but also the so-called machine learning. And I like to focus on this subgroup. Machine learning means the automatic adaptation of machines in order to learn and to approximate functionality, without having been explicitly and deterministically programmed for that. So basically, it's very, very sophisticated statistics. It stemmed from the last millennium, the 50s of the last century. But now the thing is, we have the power when it comes to calculation in order to make them really fruitful and useful. And inside then we have, as an example, also the neural networks, which you might be familiar with, and the perceptron as one special example. Okay, so you know, in terms of definitions, we could spend years. We don't have this much of time, I was told. So thank you. Next slide. You can read my, adapt to my speeding of my speech speed. Thanks a lot. So what's the main difference between classical program and machine learning, now this subgroup? I know there are various variants of machine learning here. Focus only on the supervised learning ones. So in classical programming, as you know, you define rules, you program them, you fix them, and then you fill the data into these rules, and then you receive deterministically, so we hope in most cases, the necessary results. That's classical programming. Whereas in machine learning, we said that what you have is you have an algorithm that has a lot of loose screws in it, so a lot of parameters not yet fixed and not yet determined. And what you now do is you take always pairs of data and the desired result in the first phase, so to speak. You have to train and to adapt your machine. You take these pairs and you adjust your machine and the parameters so that the results are very close to what you wish, depending on the input data. And that's how you train your parameters inside these machines that are still loose, and you have to fix them in order to approximate a functionality. Because then in the second phase, in the usage phase, in the operation phase, so to speak, then you give new data, and you hope that the result is close to what you want as a trained functionality. So the main difference is that the rules and the functions you have inside the machine learning, they are approximate. There are approximations, very sophisticated ones, yet not in the classical one where you say we have yes, I will go on soon. Not in the classical sense in which you you do your programming. Next slide, please. I already summoned, so to speak, this slide, because how you train a machine algorithm means that you have to build a data set. That is, you have to collect data and the desired results. You have to have this as an ingredient. Then you have to have this little machine with the loose screws in it and the loose parameters. And this is developed according to normal software development standards. And then you adopt this, you train, so to speak, these algorithms, and you fix these parameters in order to improve its performance. So the fourth point I've already mentioned. Yes, next slide, please. So what is different about machine learning? First click, please. I should have abandoned the presentation mode. I'm sorry for that. I thought that I was in control. So delegating sometimes is different and difficult. So machine learning implements a software structure which then adapts itself according to the sets and the pairs of input and desired results in the training phase. So it changes itself based on the training data. Then, if we have trained enough, then it's fixed. Yet this also means that as we have only an approximated functionality which we can't really see and can't really test, that means that we have to abandon this classic thought of functionality that you have defined very precisely, which is then decomposed into various software architecture and modules. So the traceability is not the key concept here, and we can't deal with that anymore and take this into consideration. This also means that it's not easy to achieve the coverage, for example, when it comes to testing and verification methods in a classical sense. And the next point, is there one? Exactly. And given the fact that it's one, okay, perfect. And given the fact that it's all statistics and statistical methods, also least square method basically is, and regression is machine learning algorithms, it means that we do not have any longer, as in classical, for example, safety argumentation, this causal relationship between input and output and functionality. What we have is we have to deal with statistical correlations, and that gives some nut to crack, so to speak. Next slide. So these are one of the hard problems of machine learning that remain and are still under research. Okay, there are challenges. We don't have problems anymore, but challenges and opportunities. So for example, the first thing is we have to guarantee or somehow to measure with some key performance indicator how complete, accurate, and statistically representative the training data is. Is it in the same environment as in the operational phase? You can, all the people and the AI expert and data management experts, which I'm not, know gazillions of examples of how important these training data and the correct statistical representativity is. Next point, please. As I said, as I indicated, that verifying the trained software is very hard because you do not have any longer this clear-cut requirements tracing and the breaking down. Next slide. So this then comes to validation of the approximated functionality because you do not have the functionality any longer. The biggest advantage of the machine learning algorithms, that is that they generalize into areas which they have not seen, is also turning into their biggest, not necessarily disadvantage, but downside when it comes to validating functionality. Also when it comes to freedom from random and systematic faults, which is one of the bottlenecks of the safety arguments, This is very hard because there might be not only as in logic, only these two things, but there might be different failure categories which we have not yet captured successfully. Next slide, please. Okay, I was too fast. Next point, please. So if you go one back, then we see the last 2 points, but that's fast. Protection against adversarial attacks. They are very sophisticated and elaborated things where you manipulate, for example, when it comes to object recognition, where you manipulate very slightly the picture. Everybody says, that's it, for example, that's an elephant, whereas your algorithm puts out a completely different thing. But that's AI specific. And the last one is, as I said, missing causality and only statistical relation. Okay, but there's a lot of fascinating research underway. Next slide, please. Those are only application examples, autonomous train, obstacle detections, and driver advanced advisory systems. So the whole industry is buzzing when it comes to these examples. Next slide. So also standardization is dealing with it. Despite the various challenges we still have in research, also standardization is going on. And as my talk has been captured by standardization and I like to briefly show that. So on a worldwide level, IEC, ISO, there's a Joint Technical Committee 1, and there's a very fascinating subgroup that is the subcommittee 42, SC42. And there they are working on a whole panoply of various standards on artificial intelligence, machine learning, neural networks, starting from terms and definitions. So if you have time, you might go into these terms and definitions groups. And then on a European level, we have also Senelec. They had a focus group on AI, and also the European Commission had a high-level expert group on AI. And this also led to the newly founded Joint Technical Committee 21, here marked in yellow or orange, on artificial intelligence. We will talk about that in 2 slides. And also, just to pick out, in Germany, for example, we also have a standardization roadmap AI. So left, right, and center, committees are popping up, even though there are still not a lot of nuts to crack. And as Gian Osvaldo, the IEC TC9 chairman, said, standardization also has to cope with these aspects of research and has to adapt because everything is going faster. As is my presentation, so the next slide, please. So on a worldwide level, some details on the subcommittee 42 on artificial intelligence, started in spring 2018, has a lot of working groups, starting from foundation standards, issues of big data, but also trustworthiness. So we would say accurateness, integrity, how often are they wrong, so to speak. Also applications, also governance applications of AI, and also general AI management system standards. So very fascinating, this IEC SC42 group. I'm part of that. I can hardly cope with all the material popping there up. Next slide, please. As I said, on a Senelec European level, we have this Joint Technical Committee 21. They had their second meeting, beginning of, I think, November. What they have now fixed is their scope. That is, they have to produce deliverables in the field of artificial intelligence and related use of data. They have to look also worldwide what's going on in SC42, artificial intelligence. And especially they have to address these standardization deliverables to address the European market and the market and societal needs. Truly enough, upholding the EU legislation and the EU values. And Senelec Railways, we are also fast because we have founded a survey group 34 on digital twin and artificial intelligence. They have been popping up and ramping up, so to speak, with a new scope and the new calls for experts underway. We had 2 weeks ago, I think, or 3 weeks ago, our TC9X meeting, and this now is gaining pace and will be starting soon. Okay, next slide, please. And this also leads me to my conclusions. So machine learning, this subgroup of artificial intelligence becomes viable, also surely enough in the train areas, and when it comes to standardization, SC9XA, the signaling port, is monitoring it, as is the railway. overall mother committee that is in an X. Next slide, please. We see very fruitful and fascinating applications in the field of RAM, that is reliability, availability, and maintainability. Yet, when it comes to the next important steps, there are still a lot of nuts to crack in AI research and AI standardization. Let's say we have to drag and to push at the same pace. So we have to also monitor how these remaining and resisting challenges develop, and when we can do the next steps, maybe also in the safety direction. But right now, I guess it's not the time. And if it were the time, then there still would be the bottlenecks of the existing functional safety standards that are, so to speak, the roof under which every safety-related electronic function has to fit. And that brings me to the end of my presentation. Thanks a lot, and thanks for your attention and having me.
Thank you very much, Stefan, for your very clear presentation and the challenges of artificial intelligence in railway. Thank you very much. So the next presentation is for the generic approach for virtual testing in the certification process. So I invite Taima Klein NVN to connect.
Yes, I am here. Can you hear me?
Yes, thank you.
Okay.
The floor is yours.
Okay, thank you. So do I share my slides?
Yes,
or?
please. Share your
Yes,
slides.
Okay. Can you see it?
Yes, perfect.
Yes.
Okay, thanks. Okay, so good afternoon, everyone. So I will present you the results from the Plaza 2 project in Shift2Rail, and which was related to a generic approach for virtual testing in the certification process. So my name is Maclean Nguyen. I'm the technical director of the railway testing agency of SNCF Voyageurs. And after working for the automotive industry for a few years, I have joined the railway sector in 2008, and my work was mostly related to materials, mechanics, and simulation. So I will first say a few words on the challenges of the virtual certification. Then I will describe a little bit the process that we have followed in the Plaza 2 project. And of course, I will more focus on the generic method itself when we want to use virtual testing in the authorization process, and I will end up with some conclusions. So first of all, the context is the following. I think everyone share it. The authorization process for putting a new vehicle in service is today quite expensive and long. And in parallel, we observed that there have been, during this more than 1 decade, very significant improvement in the quality of the simulations, even for complex systems. So the challenge for virtual certification is to use these tools, these simulation tools, not only in the design and development phase, but also in the phase of approving a new or modified rolling stock or subsystem. The benefits are quite clear: significant reduction of the authorization cost and duration, and therefore significant reduction of the LCC of the rolling stock. But we also expect to improve interoperability, facilitate the introduction of innovations, and increase the reliability of a vehicle. So when we defined the Plaza 2 project, we first stated that the situation is quite heterogeneous between the different technical fields. The maturity is various. The way to use simulations is quite various. And when we looked at it, we also raised the fact that there is one blocking issue, is when you want to use virtual testing, the one question is, how do we validate simulations? How can we decide that some field tests can be replaced? So we came to the conclusion that the challenge for the project was to define a generic method with 3 sub-challenges. First of all, this generic method should be applicable to any technical field and to any kind of virtual test, so numerical simulations, HIL, SIL, but we exclude artificial intelligence because surely we didn't feel experienced enough. The second challenge is that this generic method must be comprehensive enough to enable a decision at the end of the process. We don't want just to give recommendations and advice. What we really want is to have a process that at the end say, yes, some field tests can be replaced by simulations and your simulations are accepted. Finally, the last challenge is not to be in contradiction with the existing standards which already allow the use of simulations. And what we want is that this generic method will be implemented in a new standard. So, as we want a generic method, it was decided to lead this project within the cross-cutting activities of Shift2Rail. So it was a 2 years project from November 18 to January 21, and it was in fact a very small project with only 5 partners and only 1 expert by partner. So we were 5 people meeting very frequently during these 2 years in order to propose a method. So the process was the following. We first spent about 1 year making a quite exhaustive state-of-the-art and benchmarking exercise. So we looked into the railway standards in which simulations is already allowed to see how the requirements are defined, how deep it goes into the details. We looked at the recent research project dealing with the issue, and we have discussed with some experts of different industrial sectors, land, spatial, automotive, aircraft. Then we also had some interactions with ongoing projects of Shift2Rail, such as Pinta, Pivot, and Connector, who dealt also with virtual certifications, but in their technical field. And we sent a questionnaire to different stakeholders of the railway sector. We also organized 2 workshops in order to present the very draft proposal we have and have their feedback. And at the end, it helped us to propose the generic method, which is described in a public report, which is very easy to find in the website of Shift2Rail in Plaza 2, and which is the subject of the following slides about the generic method. So this generic method, we called it the 3 pillars approach. Generally, when people want to use simulations in the approval process, the question raised is how do we validate the simulations? How confidence do we have in it? So this is the, let's say, quite traditional step, which is the second step. But we came to the, we after brainstormings and discussions, we were quite convinced that the very first step was first a simulation categorization. Here, the aim was to consider factors that are not influenced by the simulation of the tool itself, but is more related to the product that we want to approve. Here, what we want to do is to define the level of requirement for the simulation quality, depending on the impact on safety, on the requirement, and so on. So from that, we set a target of credibility. Then we jumped into the second pillar on the simulation credibility. So here we have defined different methods to measure the simulation trustworthiness. We were quite influenced by, let's say, the NASA approach on the credibility of simulation. So we have defined a method to determine this credibility. And if this credibility meets the target defined in Pillar 1, then we can stop the process and say, okay, simulations is good enough, and we can use them to replace some of the field tests. If not, there's still an additional way to use simulations, and it's the third pillar that we call the computational measures, and I will describe them a little bit later. So thanks to these three pillars, these three steps, we are able at the end to decide if simulations is accepted as a proof of conformity. So now let's jump a little bit in more details in each pillar of this approach. So about the categorization, we have defined different factors to define this categorization. First, factors about the regulatory. Is it an issue of safety? Are the products submitted to regulatory requirements, or is it just other types of requirements, let's say specifications from the clients, for example? And depending on that, we will give a target more or less severe. We also defined some design factors more related to the product to be approved itself. So what is the technical complexity of it? What is the complexity of the system in which it operates? Which is the level of novelty, and which is the impact of the product on the essential performance of the whole system. So I will not get into the details, of course, but for each one of these parameter, this factor, we have defined the criteria to assess a level 1, 2, 3, or 4 for the complexity, novelty, and so on. And then once we have done this exercise, we will take the maximum level across the 4 sub-factors to define the design factor. So we do the same thing for the regulatory factor, and then we use this matrix to define at the end the target level for credibility for simulations. So you see that, for example, if it's a safety issue, you will have at the end a target of 4. If the design factor is very high, equal to 4, well, if it's not if you don't have a high level of regulatory factor, then you will end up with a 3 level. Okay, so with this categorization, we have set one target. Then we looked at the simulation credibility. So we have defined different factors, once again, on the verification of the tools and the models, on the validation of the tools and the model, on the quality of the input data, of the way uncertainties and variabilities are taken into account in the approach. But we also looked at some management issues, how the entities performing the simulations are organized, how the processes are clearly settled down and put in place. So depending on all this, we will define different level of credibility. For example, for uncertainties, if we are very low, it means that we see that simulations give you an idea of variability, physical tests as well, but it's not exactly the same, but we don't know in precisely what are the parameters that exhibit the difference. So one way simple to do that is to put, for example, a safety factor, just to guarantee that you are on the safe side when you use simulations. Okay, so this is the first, this is the second pillar, and for the third one is when you don't meet the target, then potentially what you can do is to add additional safety factors. Or for example, you can ask for some additional physical tests. It can be track tests or it could be a bench test, but the idea is instead of doing the whole physical test campaign, you can use your simulations, but you need some additional tests just to confirm some results obtained by the simulations. So to conclude, we have developed a three-pillar approach, and it has been presented to many stakeholders, people, experts involved in the development of methods in specific technical fields. But we also presented to ERA, to GPCR, NBRail, and Sensenelec, and we had very positive feedback. So we were encouraged to finalize the work, and it was done in 2021 in January. And the most positive of it is that it was decided in the Sensenelec that the method will be implemented in the new volunteer standard that is in progress. So there are two working groups, TC 256 GG55 and Senelec TC9X GG32, who are working on how to transform this the deliverable of Plaza 2 into a standard. So that is the end of my presentation, and I will thank you for your attention.
Thank you very much. Thank you for your presentation and the fact that you will have an outcome which will be published. So this is very good news.
It is already.
It is already. Thank you. So, thank you. Next presentation. So we'll have the new challenges of machine learning in certified system of SNCF. So Cédric Le Lyonnais and Philippe Bourdonnais.
Good afternoon, everybody. Before presenting us, I would like to make a short introduction. Machine learning is, as you know, everybody, in many applications, and no, just sorry, in many applications, and we can generate with machine learning rules, and those rules generate. It's very difficult today to formalize these rules. So we are going to share you a presentation today about the certification of systems which integrate properties of machine learning. Next.
Good afternoon, everybody. I've joined the SNCF 2 years ago, and I belong to the AI team of the Rolling Stock Engineering Center, in which I'm working on a program of DMI certification using deep learning classification technologies. I'm also working on a human detection program and crowd counting in suburb trains applying algorithms on video protection images.
Next, please. Cédric Le Lyonnais. So I worked at the Rolling Stock Center Engineering for 5 years, and I mainly work at the Artificial Intelligence Pole, and I'm involved in research and development on safety use cases. Next. So the context of certification, we have to distinguish today European certification and the certification in the broad sense. Certification in the broad sense comes to cover all the approval process, and in fact European certification is a stage of the approval process. In the European certification is regulated by a directive on technical specification of our interoperability, is delivered by a NOBO, notified body, And at national level, the qualification operational qualification is authorized by the end customer, and in the systems undergo the qualification operational. Next, please. So the challenges of machine learning certification is in line with the VIG cycle. And in fact, we could imagine a further adaptation of this cycle for machine learning algorithms when the systems need to integrate these problematics. Next, please. So we have to define properties, and DEAL, which is a consortium which brings together academics and industrials in the field of transport. They currently focus on those properties. They identify 7, and we are going to present you after that a contribution of these properties, 3 of them. It's data quality and then representativeness, the explainability, and finally, the robustness. Next, please.
Well, at the Rolling Stock Engineering Center, our team is pursuing a safety equipment approval strategy that remains faithful to the V cycle. We follow the entire industrialization processes by first working on the specification and the launch of the call for tenders to manufacturers. Next, manufacturers design and build their solution and set up a functional validation process to verify and integrate their products. And once the product has been validated, we step back into the operational qualification and integration of the safety equipment in which the product is subjected to interoperability test scenarios. These tests are carried out on a bench for qualification and a test train for an integration part. Finally, once these steps have been certified as compliant, the equipment is authorized for commercial operation. These essential steps already show us how important it is to establish a common language between the stakeholders of a project, right from the specification of a product. Obviously, the aim is to save time on the homologation processes. Integrating V&V concepts in the upstream phase of the V cycle is more and more required. For example, model by design, model checking, and so on. It's very important to take this in consideration when building an homologation process chain. And this is what will condition our approach for the future work. Next, please. It will be the same with the safety equipment, which will be able to integrate machine learning algorithms. However, the task promises to be very complicated with this type of solution, since machine learning model is difficult to interpret, which is antagonistic to the certification processes, which are based on deterministic approach. Exactly as Stefan said it in a previous presentation, this is a true paradox, because certification is based on causality, and there is no causality principle in artificial intelligence, not at this step. So we must therefore define levels of explainability to first analyze the models that have been designed. And then in the second step, we must define one or more processes which will be based on new evaluation metrics. Machine learning models are increasingly efficient, but are even less interpretable, like neural networks, for example. It was therefore important for us to consider in our approach the detectors that we encountered mainly for the recognition and localization of shapes in the computer vision image.
Next, please. So, it's very important to establish ties between stakeholders. For example, at the functional validation stage, we could highlight a level of explainability to analyze the robustness of the detectors. Our contribution, we currently focus on the relevance, but maybe we can find other metrics. For operational qualification, the view is different because the detector is within the system. So the analyze is on all the systems, and the system has to be put in realistic operation conditions. And the qualifier has to define test scenario in compliance with that. And at the end, we could help the operator too with another level of explainability to assist the qualifier in his analysis. Next, please.
Our approach shows first feedback. Before considering working with a detector, we started to analyze a classification model, which is a neural network, but has fewer layers than a detector. Here we can see an image of a part of a DMI. The classifier, we only assign a class to the recognized shape in an image. In this example, the model in question classifies the pictograms that are found on the drive machine interface in trains. On the upper part of this workflow, the model in question is conventionally subjected to a stage of evaluating its performance based on test data. The metrics used for this type of model are so-called scoring metrics, which, among other things, measure precision. The innovation consists in the low-level part of the workflow that we have set up to analyze the model. In this step, new metrics were identified to assess the relevance of the decision taken by the model. The relevance is represented by a mapping of the pixels that have been designated. In our case, these pixels are consistent with the shape which has been recognized, but sometimes outlier pixels can be found and they can bias the decision. So on the next, to go further, we intend to build, yes, thank you. To go further, we intend to build a detector which, in addition to classification, locates the shape that has been recognized in the image. The architectures chosen for this type of model present neural networks with many layers to first reduce the region of interest and then classify the shape. This use case considered in the study is about detection of trackside signal. At the moment, it is now a work in progress, so we are not ready yet to fetch performance indications, but this is a project. But like for the classifier, the ultimate aim is to define new location-specific metrics. This is the ultimate aim. From these metrics, we'll be able to build a robustification process, as Cedric shown at the time, to rework the detector by specifying the training dataset.
Next slide, please. So, at the operational qualification stage, the principle is close to the functional validation stage. On the one side, we have detection predictions with scoring metrics. And on the other side, we have the analysis with metrics to assess the behavior of the system. if we take an example, for example, at this stage, the ATO with a signaling detection, test scenario have to be created by the qualifier. And one of these scenarios could be a flashing light and adapting the speed of a train, or the crossing of a stoplight. And so we have to consider the state of the light during all a sequence. So for that, we have a metric like a time integration, but it's not enough, because maybe in worst case, like weather conditions, according to weather conditions, to environmental events, or even adversarial attacks, it's very difficult to be right with the data. So the test data have to be simulate the realistic conditions, and one metric could be imagined for that. It's the out of distribution, in order to be sure that the distribution of all the test data are at the limit of the distribution of the train data. Next, please. Thank you. Sorry. Another level explainability could be for the certifier who establish the safety rules. So, in fact, we can find that at the end, these rules modified or adapted could be also integrated in test scenario. Next, please.
So, in order to conclude, we have faced these challenges. First, integrate certification process for machine learning algorithms, and then improve reliability in AI approval processes, and then provide explainable AI levels in accordance to the audience. And at the end, our perspectives are to be able to exploit a new API approach to both robustify and monitor detectors, define new metrics of explainability, and define a taxonomy of certification concepts from explainable AI levels.
Thank you for your attention.
Thank you for this presentation. So we now continue with another important topic, which is digital automatic couplers. So the delivery.
Yes.
So
hello.
Christoph Klose, are you here? Yes?
I'm here. I hope you can hear me well.
Yes, very well. Thank you. The floor is yours.
Okay, thank you very much. So thanks a lot giving me the chance to introduce to you today the digital automatic coupler. The topic has mentioned already in the morning a couple of times. It's very important, I think, for the future of rail freight. A few words to myself. Christoph Klose, I'm working for Siemens Mobility in Germany. I'm heading there the yard solutions business, so mainly for freight. I have a background mainly in rail automation, and on top of my responsibilities in Siemens, I'm also leading in the EDP, the duct delivery program, the work package 1. Maybe let's go to the next slide, please. So, and what is it all about? And it's, let's say, coming from manual to automatic processes. And you see here as an example, the coupling, and the whole project goes around coupling, but what you will see in the next slides and here in the next minute, that what we're talking about is going far beyond automatic coupling and uncoupling. It's really about automating and digitalizing the processes for building freight trains. Maybe let's go to the next slide. What you could see here a little bit is the areas where we are challenging, because what we really have to make sure is that the rail freight and the infrastructure getting from a bottleneck will lead to a backbone, because the potential to save emission in transport is immense in rail. But to make this really happen, we have to increase the productivity and the quality. And as a symbol for productivity, we have to go from manual processes towards automated processes. And on the quality side, we have to go from paper to digital. And maybe we can come to the next slide where I go a little bit more into details. So what we really have to make sure is that we really have to use our capacity in a better way. So we have to make more use of the existing infrastructure with faster trains, with more punctual trains to also reduce the disturbance. Important is also to increase the productivities. As already said, we have a lot of manual processes here around handling of freight trains. So the productivity have to be increased. We have a chance to increase speed and also the efficiency of the assets. Quality is a topic because freight trains are currently very well known for not being on time or being unreliable, and this have to be increased. We really have to make sure that we can handle disturbances in a much better way, in a much more automated way, and inform the customers much better. And this is also something where the digital automatic coupling should contribute significantly. But when we're going a little bit to some other aspects, it's also the worker safety, because the manual processes in rail freight are sometimes, let's say, taking place in a different environment, in a dangerous environment. They're taking place during day and night, all weather conditions. So it will also help here with automation to improve the situations also in terms of safety. On the economics, it's a huge program. You will see later on that this is really something what's touching the whole sector of rail freight in Europe. It will create a large opportunity for technology, but also for creating new employment opportunities in Europe, not necessarily only on the supplier side, but also on the operator side, because if new services can be offered, this will also make the business, and this is the aim of the operators, a much better one. And last but not least, rail is highly contributing to the Green Deal. Each ton of freight, what can be transferred or can be shifted from road to rail, contributes to the CO2 reduction, because the rail is much more environmental friendly compared to the road. Therefore, there's a huge need to make all this happen. Can we go to the next slide, please? So what you could see here are the use cases, because I mentioned before, when we're talking about the digital automatic coupler, we're not necessarily only talking about the coupling and uncoupling processes. We're talking about some other processes, like automatic brake testing, like building heavier and longer trains, to have train integrity, to make it feasible also in the future to introduce ETCS level 3 also with freight train, to introduce EP brake to improve the braking performance, what also then lead to increased speeds, monitoring the condition of the wagons and of the goods for the customers, to apply automatic parking brake to even further automate the processes and make the things much more efficient. I mentioned also the automatic uncoupling. We would also then not only couple automatically, we would also uncouple automatically. That means here in this case we're not uncoupling. We would like to support with the digital automatic coupler also the wagon inspection, also one of the processes, pretty time consuming, but this will go together with maybe video gates and checkpoints in the infrastructure. And last but not least, we would also supporting with the digital automatic coupler longer trains, distributed power concepts, together with the IP brake, to really help that the rail transport will get more efficient. Maybe let's go to the next page. And on the next page, I would like to also give you some idea what is the time frame we're currently talking about. Because what you can imagine, if we introduce a new coupler in Europe, this is something what has to be done also with a sound migration strategy. And currently in Shift to Rail, in the EDDP, European Duct Delivery Program, we're currently working on migration scenarios. And we are currently, and this, please take this as an indication, we are currently working this out also in the context of the Europe's Rail. How to integrate and how to, let's say, migrate the existing rail operation, freight rail operation towards a rail operation, freight rail operation based on the digital automatic coupler. And you see here the second half of this decade will be pretty decisive. So the first half of this decade will be mainly for the standardization and the development, and the second half of this decade will be then the implementation and the migration of the whole system towards this. We are evaluating scenarios currently. One very short scenario with a preparation time, but maybe we also come to a little bit longer scenario. But for both, it's very clear we have to do the conversion towards the DAC until the end of the decade, because the process during the migration is pretty challenging also for the operator. Therefore, we have to make it as short as possible. Maybe let's go to the next slide. Because if we're talking about the DAC and introducing a new coupling system, we have to understand that we have approximately 500,000 freight wagons and approximately 17,000 locomotives in the network of the UIC. And all of them, not all of them, but 90% of them have to be converted towards a digital automatic coupler, because the wagons in Europe are pretty freely exchanged, especially the ones of the core fleet. And what really is a challenge here, that these wagons and locomotives are owned by different rail operator, and we have to make sure that the migration towards this new coupling takes place in a pretty short time, and is highly coordinated, because all the different stakeholders had to be synchronized very well. The equipment will be manufactured later on by different manufacturers. Here now standardization kicks in, because you can imagine this has to be fully interoperable, and therefore intense work in specification and standardization is required. Sen already started the work on the standard on the mechanical part. Senelec TC9X also started a couple of weeks ago. And on top of that, also the TSI documents, the adaptation of the TSI documents are also kicked off. So standardization of the equipment will play a key role here. Maybe let's go to the next slide to explain you a little bit what are the elements of the standardization and specification. So one element for sure is the coupler itself. You see here the two pictures as a sample, the coupler of the wagon, the coupler of the locomotive. But we're always talking about a digital automatic coupler, and digital automatic coupler means, sorry, can you stay on the slide for a second, please? Thank you. We would also introduce an energy system. That means we would like to run a cable through the whole train to provide energy to all wagons. But if we would like to run such a cable through the train, we also need an electrical coupler, and you can imagine such an electrical coupler have to be standardized, that the wagons from different operators and different manufacturers are fitting to each other. And last but not least, we will also establish a communication system through the train to make sure that the locomotive can communicate with the wagons to enable the use cases you have seen before. Now we can go to the next slide, please. And here you see, maybe the picture is a little bit busy, but only would like to explain to you a little bit what is the complexity we're currently talking about. So we have, and here we're talking about the energy system. We will have equipment on the locomotive, what is supplying the power to the train. Sometimes people think, oh, especially electric locomotives, power is available, but we need, let's say, not the power is currently available of the locomotive. We have to make sure that the power is on the right level. Feed it to the train. You could see here it will be a cable system, cable-based system, providing the energy to all the wagons. And then on the wagon as such, we will have a power management system supported by an energy storage to make sure that the applications are also working if the locomotive is not providing energy, because the wagons are also parked for quite some time and therefore they have to work. But what we also said, it's important that we also standardize not only the interface between, for instance, the locomotive and the wagon, but we would also standardize the interface to the applications on the wagon as such, because we would like to make sure that also on the wagon you have interoperability, so that you can also later on can apply additional applications, maybe not available today, to the system. So therefore, our focus of standardization is not only the interfaces 1 and 2, where we are communicating or transmitting and aligning between the locomotive and the wagon. We would also make sure that on the wagon we have a standardized interface to the consumers and to the applications. Let's go to the next slide. Here I would like to introduce to you a little bit the communication architecture. I mentioned we would also provide communication, and if you today think about communication, there are general 2 aspects of communication here in the DAC. One aspect is the communication in the train, especially the use cases you've seen before. They needing a communication within the train, and this is something what we would like to have shown here with this, what we call it interface A, where the wagon are communicating with the locomotive. Locomotive, the master, wagon will be the slave. But this communication and this interface is pretty challenging, because what we have to really make sure here is that we have to find something what is really robust, because we are coupling under all conditions over coupler, coupled not in workshops, they are coupling in shunting yards. So we have to find a communication system what is really robust enough to be reliable also under these kind of conditions. We will see this in a minute. We are looking into various different standards, and we have to find the right communication physical channel here. But it's not the only interface we're currently looking at. I also mentioned that we would like to look into have a standardized communication on the wagon as well. Here is a little bit easier, because here we're talking about, and this is what we see here, the interface B, where we say, okay, this is our short-range communication. Ethernet would be here maybe a potential standard, but you can also consider other standards. But we would like to provide also a standard here on that level to make the system interoperable and also extendable in the future. And I would also mention one other aspect, that a lot of data will be generated on the wagon and on the locomotive. And these data are not necessarily only be used for the operation of the train, also on the wayside by various stakeholders, starting by the railway undertaking, by the wagon keeper, infrastructure manager, but also customers would like to need the data. so that we say, okay, these kind of information have to be transmitted directly from the individual wagon towards via mobile communication, like the telematics system of today, doing it directly to the operator or to the supplier, and then distributed there to the other stakeholders. We are not using the locomotive as a data concentrator, so this kind of concept we would also like to introduce with the DAC. Okay, let's go to the next slide. Here you see the classical communication pyramid, and what we are currently focusing and what we are currently investigating is the physical layer, the lower layers to find, and we are currently testing in the project DAC4EU funded by the German Ministry of Transportation, various physical layer to find out what is the most robust physical layer for such an application. And then what is our aim is to apply on the higher level already existing standards like ETB or what's also currently going on in Connector 2 to find there potentially existing technologies, but also existing standard to be applicable here. Also on the physical layer, we are not necessarily looking to develop something new. We're also looking into standardized communication system, but they have to be robust enough to sustain and reliably in the environment. Maybe then let's go to the next slide. I mentioned before that all of this is only helpful, the energy and communication system, if we have put the application on top. And this also requires standardization, because if you would like to apply, for instance, an automatic brake test, the equipment of the different wagons have to also support the same process and have to work in the same way. So standardization will also be a topic not only on the energy and communication system, it will be also a topic one level higher on the applications. So, and in EDDP, we will start soon also to tackle the standardization of these packages in the context of the Europe's Rail Joint Undertaking. So maybe let me come to an end to my summary slide. Thank you very much. It's very important because the DAC is a key enabler to really to make sure that more freight can be converted to rail to achieve the 30 by 30 target. And this can only be achieved by increasing the flexibility, because we have to reduce the transport time to improve the reliability, and flexibility is also a very important topic. As said, the DAC is one of the central elements to optimize the current processes, and we have to do everything to ensure the rollout of the DAC in the second half of this decade. And this really requires all stakeholders to work together. And my last sentence I would summarize with: failure is not an option. We are not the first attempt to introduce an automatic coupler in the freight rail environment, but this time really we have to make it happen. We have to do everything that it works, because if you see what's going on the road, that by the end of the decade we might see self-driving electrified trucks on the roads, and if then the rail and the freight rail is still driven by a lot of manual process, then it will be very difficult to convert even more share and more freight to rail. Then therefore we have to be successful there, and we need the help of the whole sector to make it happen. Thank you very much for giving me the chance to introduce this very important initiative to you. Thanks a lot.
Thank you very much, Christophe, for this presentation. As you said, there will be lots of data that will be generated, and this makes the links with the next presentation, which is a rail system model on to rail, which so is presented by Pierre Tan.
Thank you. Hello everybody, I'm Pierre Tan, I'm head of digital modeling at UIC. I'm also a contributor to the FRMCS project that was presented by Jean-Michel this morning. I'm also involved in European spectrum regulation for railways. But in the context of this presentation, I'm going to talk about two particular initiatives that UIC has launched to help digital continuity in railway system models, and with the ultimate goals to reduce cost and foster innovation. We can go to okay. So, as we have seen from many presentations, the railway system is complex. For it to operate efficiently, it needs to be to operate as a whole, but nevertheless composed of many subparts. It's a complex system of systems, and as such, there has been various standardization efforts to represent and to model these various systems, such as signaling, infrastructure, telecom, and a few others. And next slide, please. And the challenge is that we already see that we already have multiple models within the railway domain, but the railway domain doesn't exist as a standalone. It's part of the greater ecosystem. It's part of public transport as well, for which there are efforts in terms of modeling as well, and here the icon is one of the trans model from Sensenelec. That's one of those models. And the railway system is also part of a greater set of issues for society, such as environmental impacts of transport and things like this, for which all these initiatives have their own set of standardization for modeling purposes. So, next slide, please. The issue we're facing with this flourishing of various models is that on their own they actually simplify or help solve some business problem, but nevertheless they are still fragmented, and as such they lack digital continuity both across domains, as in if we want to move from one, if we have a system that is modeling one part of a domain and we want to use it to use some of its data for another subdomain, we usually need to do either model transformation or at worst to redigitize completely to actually be able to do these kind of studies. And there's also digital continuity, discontinuity across phases of the model, in the sense that for different stages of a railway project, we might also face difficulties reusing directly in a digital manner what has been done at the previous phases. And ultimately, this digital discontinuity is a source of cost because it takes time to do this transformation, and it's time and effort that are actually not useful to what the railways are trying to do. It's essentially wasted efforts. And last but not least, it's also a source of vendor lock-in, which itself is a source of cost, to the extent that if it's too painful to actually move objects from one phase to another or between domains, then sometimes it's easier to stay locked in one vendor environment, and that's something we'd like to prevent. So the Links for Rail project, which is part of the Shift to Rail initiative, that's something that they identified back in end of 2019, and that's where the kickoff of Links for Rail project took place. And here we see on this slide, which is what they had provided at that time, they identified this fragmentation of the landscape and the need to be able to interplay and interchange between various models. And that's where, next slide please. That's where the notion of the conceptual data model of Shift to Rail took place. And particularity here is it's viewed as a federation of models. As we know, there's a famous, or some of you might know, there's a famous KCD cartoon which says that when there are 14 competing standards and you want to unify them with a 15 model or standard, you end up with 15 competing standards. And that's what we want to prevent. And as such, that means that if we don't want to unify them into a new standard, then we need to federate them. And here federation is to say we interlink standards or models between each other where relevant, but they still retain their independence, and their independence allows them to evolve And so essentially to progress on the domains that are actually modeling, while still be able to be tied to the rest of the digital ecosystem through the digital continuity. And the spirit of what the CDM wants to do can be exemplified through 4 operative words. The first one is openness. Openness is about giving a model which has no barrier to use, and for which there is also no hidden vendor lock-in, such as certifications, for example, that would be mandatory to be able to use that model. And it's also openness towards other other digital models, in the sense of the second slide that I presented, which is that if we use open standards, then we can actually link them to other digital model present and explore new problems. The second one is the federation, which I briefly glanced over already. So here, federation is about linking concepts between different models together, and it's about leaving each of the models that are federated their own independence of evolution in order to benefit from their evolution while still being able to tie them to the ecosystem. Third one, and that's related to this linking, we need strong semantics. And here, in the particularity of the CDM, we are exploring the use of ontologies as a formal representation of knowledge, and with the ultimate goal that first it's formal in the sense that it's non-ambiguous how concepts between models relate to each other, but potentially more importantly, it's batch-in processable, which means that we can create new knowledge, amongst other things, from this formalization of the relationships between various models. And an additional point about semantics is that, and we are also already facing it as part of the convergence effort we're trying to do in the CDM, is that sometimes, even with the best intention, models can be a bit ambiguous as to what they are trying to cover, and it's very important to work on appropriate documentation of the models to facilitate or to prevent misinterpretation, and ultimately limit future additional processing to correct this kind of errors. And the fourth one is related to the continuity across project lifecycle and also across project dimensions or project domains. And so those 4 aspects are what the CDM is trying to address. And if we move to the next slide, please. So if we have that, that would allow us to move objects from the various phases without losing tracks of where they are coming from, and that can lead to be able to consistently track, link requirements to the way they are implemented in actual railway projects. And it's also the vertical movement between domains, which allow to take the knowledge from one domain to benefit it in a second domain. And that also would be desirable, but nevertheless, to actually get there, because we have this constellation of models, we need to identify what they have in common, where they overlap, because naturally, being independent, they might actually try to model the same thing on their own, and sometimes they have modeled it the same way, sometimes it's in a slightly different way, and that's one of the key areas of work that will take place in X4L. And finally, there's also the need to identify a way when they have either commonality or they overlap to potentially identify new concepts by which we can link them that might be at a higher level of abstraction, but that ultimately would provide the bridge between those models. So next slide, please. And so that's where the 2 initiatives that UIC is working on are coming into play, and these are essentially 2 building blocks to establish this digital continuity between models. So the first one is RSM, Railway System Model, which is known to some as a rail topo model before. It's a generalist model in the sense that it provides high-level fundamental notions of railways, but it doesn't intend to model by itself the entirety of the railway. So the spirit of the RSM project is to work with more specialist projects that are doing specialist modeling like U-links for signaling, for example, or IFC rail in the domain of BIM for railways. And to be able to provide this anchor and this backbone to these other more specialist models. A particularity as well is that it's built on the solid principles, and as such, it's actually quite easy to extend, to introduce new notions. And one such project where it demonstrated it was rather easy to implement a new domain was in our collaboration with the Optima project of Gabriele, which we will hear about in some 15 or 20 minutes from now. Where we introduce, for example, a weather package to address the needs of the Optima project. The second project or initiative of UIC is OntoRail, Onto for ontologies. And ultimately, it's intended as an encyclopedia for railway knowledge. That's one thing. And also, second thing, it's a tool to establish consensus as well. Next slide, please. So just a quick word on RSM. So when I was talking about fundamental notions for railways, so it's a successor of Rail Topo model. And as such, topology was where it was coming from to be able to describe in the topology of railway networks at various scales, at micro level, but also at much higher granularity. But also fundamental notions such as positioning or location around on a railway network, such as linear positioning, for example. As part of the collaboration with IFC Rail, the geometry of tracks, we've actually integrated the way they were describing geometry in the railway system model. And one particular item I wanted to highlight was that's new in the recent release of RSM. It's the specification, observation, and prediction package, which is intended to address, amongst others, predictive maintenance use cases by providing a generic abstraction about the various stages of something we might want to measure. That being said, as I briefly explained, we don't intend to reinvent what is already present, and as such, we are taking whatever open standards are already available and making them, adapting what they provide for railway purposes. And here, the first one that I listed here is the W3 SOSA SSN, which is for sensor networks. And that's at the heart of the description of the specification, observation, prediction package. But also standards like coming from OGC for positioning, for example, or even glyph ontology for description of companies and things like that. And finally, on a strong emphasis on collaboration, as I mentioned before, and I've listed two of the main partners of the RSM project, which are U-links on the data prep for signaling, and IFC Rail for the BIM business. Next slide, please. And so for OntoRail, so it's a project in development, because RSM has been started back in 2016, so it has quite an history there, but OntoRail is actually from mid-2019 and is still in development, but we have a working prototype in place. And the idea is to consolidate at the ontology level the various knowledge of the railways models, and to be able to provide through ontologies the linking between the relevant concepts, and using ontologies again to provide this formal description of the knowledge, which we can then use, for example, to make new inferences about the railway system knowledge. The important thing as well is that because there's all these models, there's a consensus that we need to help building between domain model experts, so that they are in agreement about the fact that the concepts are related in a certain manner, and that's one of the key features we add. So next slide, please. So in short, what OntoRail provides at the moment, it's an import mechanism for UML models in XML format into a knowledge graph. But also we support natively ontology import. One of the models we imported is the European Rail Agency RINF model for registry of for interoperability. And so we import them all into RDF knowledge graph. So I've listed on this slide the ones that are as part of Links4Rail imported: RSM, ULinks, AFC Rail, X2Rail4, and the RINF, as well as Transmodel. Transmodel was originally not considered, but thanks to ongoing work in Links4Rail, we actually also imported it. Next slide, please. Then, once we have all this knowledge in OntoRail, we provide unified searching and navigation inside the models. And there's also, so it's in the form of a tree view where we expose the various properties of the objects that are present in the models. And the second thing is a graph view to see objects in the context in which they appear in the models in which they're coming from, and also in relation to other concepts in other models that would have been established through the tool. Next slide, please. We are also able to do parallel browsing of these various models. That's to facilitate understanding the differences between concepts and build this consensus. Next slide, please. And then for the establishing the consensus, once we establish that two concepts are related, we have a working process through a forum that allows the model experts to agree on the relationship between those concepts and ultimately to record it as a formal knowledge in the OntoRail knowledge base. Next slide, please. And finally, we can export that knowledge either as a federated through a Sparkle endpoint or as an export in an ontology format. Next slide, please. And finally, so what we were trying to do, that I explained before, was where RSM is coming into play, it's creating this anchor between concepts. And OntoRail is the tools that we are providing in order to identify the commonalities between concepts, between various models, heterogeneous models. And so far we are at the early stages of recording now some of the consensus between model experts that are involved in the Links4Rail projects. And with that, I'll conclude my presentation. Thanks for your attention.
Thank you very much. The next presentation is related to cybersecurity. So, as you may know, so TC9X published this year a new standard regarding cybersecurity in railway, and so now we have the point of view of Unife.
Yeah. Good afternoon.
Nicolas?
Yes. Can you hear me?
Yes. Very well. The floor is yours.
Do you have my presentation or I share my screen? Okay, I will share my screen. So just confirm that you can see my presentation. Would be
Yes, we see it.
Okay, perfect. So good afternoon, everybody. First of all, I would like to thank the organizer for having invited Unife at this ICT for Railways event and in this panel on digitalization. So my name is Nicolas Furieux. I'm the head of Technical Affairs Unit in Unife. So I'm responsible for all the technical affairs activities dealing with research innovation, but also standardization and regulation. I will not present Unife because it was done this morning by my Director General, but today what I would like to present to all of you is the Unife vision on cybersecurity in railways. Because it was mentioned several times today, rail is a system of systems. We are using more and more digital solutions, meaning also there are more and more cyber threats, and we should provide some solutions that will be cyber resilient. So on the next slide, if it works. So, yes. So regarding the context on cybersecurity, so cybersecurity at European level is a topic discussed in various DGs of the Commission. So DG Connect is the DG who is leading the discussion, but of course for transport, DG Move is involved, DG Research for research, and DG Grow for the industrial aspects. Also, there are some European agencies. One of them is the European Agency for Cybersecurity, ENISA, who is really responsible to implement the strategy of the Commission on cybersecurity, and for rail, the European Union Agency for Highways, who of course is involved in the discussion. There are also other relevant organizations like Sentinelec at European level, so standardization bodies, but also ISO and IEC at international level. So cybersecurity is a topic which is intensively discussed in Brussels. It's of course to create this cyber resilience at European level, but also at worldwide level. So that's why in December 2020, the Commission published its new strategy for cybersecurity. And in these documents, there are three key priorities. So the first priority is addressing resilience, technological sovereignty, and leadership. So meaning that the Commission would like to reform the rules on the security of network and information systems. The second key priority is to build operational capacity to prevent, deter, and respond to cybersecurity threats. So meaning that what the Commission intends to do is to try to implement a progressive and inclusive process to face, let's say, to define a strategy for cybersecurity, and this by involving all the member states in the discussion to try to have a joint approach regarding the cybersecurity issue. And the last priority is to advance at global level and also to have open cyberspace, so meaning to try to discuss with international partners, so on all other continents, to try to exchange on the cybersecurity approach and issue. So this is the strategy from the Commission. But now, what are the tools to implement this strategy? So one of the tools is the famous directive on the security of network information systems, and this is the second version of the directive that aims at trying to harmonize the cybersecurity requirements for critical infrastructure in Europe, in the member states, so addressing complex architecture, also addressing the security of the supply chain. So it's not only for rail, it's for all the sectors, but rail is one of the sectors which is concerned by this directive. And also for this, so to try to implement and to improve the cybersecurity resilience in Europe, there was a Cybersecurity Act that was published in 2019, giving, let's say, a permanent mandate to ENISA, so to this European Union Agency for Cybersecurity, and also to ask ENISA to start defining a cybersecurity certification framework for ICT. In terms of other initiatives that are relevant for the rail sector regarding cybersecurity, so a platform has been established 2 years ago. This is the ISAC platform, so it means European Rail Information Sharing Analysis Center. So this platform is bringing together operators, system managers, but also suppliers, sharing information on the various cyber threats and trying to learn from each other and trying to define also a way to improve the cyber resilience of rail assets. And on the standardization side, Sentinelec is fully involved, and especially the Sentinelec Working Group number 26, who has published a technical specification, so the first technical specification for cybersecurity in highways, covering all the subsystems for the rail sector. And this document is key for UNIFE, and I will come back on this later. So in terms of landscape, what we can, let's say, notice today is that cybersecurity requirements are addressing different sectors. You have a legal framework, but the legal framework will not solve all the issues. And also, as you have this trend of digitalization of the rail transport, meaning that we are facing more and more cyber threats, so we need to define a process in the rail sector. We need to define common approach to face those cybersecurity threats. It's also important for the suppliers to have an harmonization in cybersecurity requirements. I mean, we would like to avoid a situation where we are facing different requirements from different customers. So that's why it's very important to discuss all together to define the right approach to deal with those cybersecurity threats. And we believe that we are at the beginning of the journey, and we need to work all together to define the joint strategy and the tools that will allow the sector to tackle this cybersecurity issue in a proper way. So that's why what we did as UNIFE with our members, in September 2021, we have published our cybersecurity position paper for the highways. So this document is available on the website of UNIFE. And in this document, we have identified various challenges, so short-term challenges, mid-term challenges, and long-term challenges. What we believe are, let's say, the key areas in which we need to investigate or we need to promote to, as I said before, to make sure that the rail transport will be cyber resilient in the future. So I would like today to present some of the challenges identified in this document. So the first one is regarding standardization. As I said before, a major milestone has been reached mid of this year. This is the publication of the technical specification 5701, which is the first technical specification for cybersecurity for rail. And in this technical specification, there is, let's say, a wish to try to have a unified approach for cybersecurity for the rail sector. And that's why now that this technical specification exists, it's very important to make aware the sector about it and to raise awareness about this to make sure that all the actors in the rail sector, being companies, being SMEs, are aware about those challenges and can work, let's say, consider in their development of products or in their development of processes the cybersecurity. And also, we believe that this technical specification will be used as a basis for the development of the EU cybersecurity certification framework for rail. And as I said before, this will be a task of ENISA to develop this ICT certification scheme. And we really believe that as a first document, as a first basis, this technical specification should be used. Also, we are not only thinking at European level. As I said before, we need to connect with international level. So that's why there are some ongoing discussion on how to promote this European specification at international level and how to also push for a migration of it at international level. So discussion have started, and we believe that we should, let's say, continue and support this approach to make sure that the European, let's say, interest or strategy is next promoted at international level. The second challenge is regarding the legislative framework. As I said before, the new NIS2 directive now will have to be transposed in the EU member states. You all know that transposing a directive would trigger some additional questions or some potential additional issues. So we should make sure that the transposition of this directive in the member states will be done in an harmonized way, at least for the rail sector. Again, to avoid to have different national rules that will pop up in the future, because you all know that one objective of the rail sector is really to clean up the national rules and to get some European rules harmonized, European harmonized rules. In terms of cooperation, so I mentioned before the ERISAC as a platform for cooperation in cybersecurity. We believe that this platform will be very useful to collect information on cyber threats and to try also next to define some mechanism to find some solutions for those cyber threats. So we need to improve the exchange of information with our customers, so infrastructure managers, operators, so involving suppliers. And that's why, as UNIFE, we are supporting this approach, and we also are involved in the discussion with the ERISAC. Today, you had many presentations on research innovation projects, presentations that were very, very interesting. And several times it has been mentioned that if you speak about digital solution, like ATO, for example, you will have to consider the cybersecurity in your requirements or in the solutions to be developed. This is also the case with FRMCS. So cybersecurity is really a parameter that has to be tackled more and more. And that's why, as UNIFE, we are calling the Commission to support a cybersecurity research innovation project. So in the past, it was done in the Shift to Rail. There was a specific technology demonstrator in Shift to Rail. But now with the new Europe's Rail undertaking, we believe that cybersecurity should be still assessed as a transversal topic, and there should be one part of the new GU, one part of the programs that will address the cybersecurity, being for various subsystems or processes. But as I said, cybersecurity is also a topic that is evolving quite fast, so meaning that there are some major technological advancements done in other sectors, like supercomputing, like quantum computing, blockchain, artificial intelligence. So meaning that there will be, let's say, those new technologies that will be implemented later on the market or will be used by the rail transport sector. So it's also important to monitor this, to be aware of what might come in the rail sector in the future. We can use those technologies to maybe also reinforce our cybersecurity resilience. And that's why we believe that this task should be addressed at European level, so with the rail sector, to make sure that we can anticipate or we can use technologies from other sectors to increase our cybersecurity resilience. The last short-term challenge is let's say, is linked to the rail sector or to the rail transport. It's what we are calling a particularities in cybersecurity within the rail sector. So meaning that we are some assets in the rail sector with a long life cycle. So meaning that those assets are becoming quickly obsolete from a cybersecurity perspective. So we need to find a way to also consider this aspect, to try to include the new processes that will allow to consider the cybersecurity threats that will, let's say, evolve on a day-to-day basis, to make sure that the rail assets will still be safe from a cybersecurity perspective. So that's why this is a discussion we'd like to have with the rail sector, how to find the right process or the right mechanisms to make sure that the rail assets will continue to be cyber resilient in the future. In terms of mid and long-term priorities in cybersecurity, so the next steps we believe that will be that the rail supply industry will have to build its IT infrastructure, so to reach the status of quantum secure and crypto agility. We also expect that rail sector will have to discuss with other transport mode because we have to also think about the multimodal aspects. Cybersecurity is not only linked to rail, it's linked to all modes of transport and to many sectors. So we need to also have this discussion how to address cybersecurity at multimodal level. We also expect that there should be some inclusion of strong cybersecurity criteria in the new technology to be implemented in the future. And this will have to be secure by, let's say, considering the product life cycle and meaning secure by design. So there will be need to have some cybersecurity requirements for the design of the new technologies. And also we expect that the first step will have to be cybersecurity at project level, but next will be addressed at the processes level. So meaning at one upper level, so to have authorization not only for the project, but for the processes. Last but not least, it will be very important to create discussion with other sectors. That's why we also believe that as a mid and long-term challenge, we'll have a need to increase the cross-sectorial cooperation. First, also to learn from other sectors, but also to try to implement in a quicker way new solutions or new technologies that could, again, help the rail sector to face those cyber threats. So in the UNIFE position paper that I invite you to read, where we identify some recommendations. So just want to highlight that for us today, the key recommendations, I mean the ones that we consider that should be targeted as a priority is the number 6. So meaning that we need to support cybersecurity awareness in the rail sector. So we need to promote as much as possible this new technical specification that has been delivered by the working group number 26 of Senelec. But also we need to work jointly with ERA and ENISA, because ENISA will have the responsibility to define this, certification scheme, cybersecurity certification scheme for ICT. And of course, this will also to be linked with the work of the European Rail Agency, and especially the update of the TSIs. So this is the message I wanted to present today to all of you. It's a pity that I could not come to Toulouse, but of course, as a conclusion, I would like to say that I would like to encourage you to have a look at our position paper. And as UNIFE, we are really ready to discuss with any stakeholders on cybersecurity topic, because our wish is to make sure that what we will deliver, what we are delivering or will be delivered in the future will be aligned with the cybersecurity needs of the rail sector. Thank you very much.
Thank you, Nicolas. Thank you for this clear presentation of the challenge related to cybersecurity. To complement what you said, yes, at IEC level, the work has started related to the development of a new international standard on cybersecurity. Thank you. So the next presentation is Shift to Rail Optima. So Gabriele Cecchetti, yeah.
Okay, hello to everybody, and thanks you for giving me the opportunity of presenting the Shift to Rail Optima project. which is this is I am myself, and I am a researcher of Scuola Superiore Sant'Anna, and here are on behalf of the Optima Consortium, and I am a technical leader of this project. Next slide, please. I want just to give you some context about how this project is born. As you know, the infrastructure manager use a traffic management system to control operation about the traffic, energy, and any systems that have on their infrastructure. The problem with the current systems, the current limitation is that each country has different traffic management system, and inside the same country can coexist different ones. And different systems use different standards in communications, and there is a lack of standardization between the data exchanges, the data structure used. So, to overcome these limitations, the Shift to Rail is trying to implement a new technology for traffic management system that have the goal to create standardized frameworks. Merci. Standardized frameworks, new interoperable data structure, messaging system that are in real times, and the standardized communication infrastructures. So next slide, please. So the Shift to Rail the Shift to Rail joint undertaking as thinking to set up a technological demonstrator that they call technological demonstrator 2.9. And this demonstrator should be implemented by the Optima project. That's as a goal to demonstrate, to create a demonstrator which is based on a standard communication platform that uses standardized data structure, and let an interoperable exchanges of information between the different systems that are linked to this communication bus. Next slide. So this can be achievable following these three technical objectives. The first one is creating an integration layer that's allow the communication. The second one is specifying a common data model that will be used to define a common data structure to exchange messages, and then standardizing all the building blocks of the workflow. So using a standardized operator workstation, and more than this, using an application framework where you can deploy your the application of a traffic management system in a plug and play manner. Next slide, please. And so the Optima demonstrator will enable a new application for traffic management and traffic control, and will enable the integration of new functionality that are developed also in other Shift to Rail projects, and will allow the integration of new technologies and functionalities, like, for example, functionality for ATO, for moving block, and so on. And in the next slide, next slide, please. I'm going to show you what are the general architecture of the optimal projects. The core is in the middle where you have the bus that is the integration layer, which is API and its common data model. Then on the bottom, from the left to the right, you have the rail business service that can be interlocking system, RBC, maintenance service, energy management system. Each of these services is connected by its own legacy protocol, for example, in C4 proprietary protocol, to a client that is developed in software and is able to talk with this field infrastructure. And then there is a translation service that are the interface service, and these services are able to send the information to the integration layer. This exchanging information happens between a publish-subscribe protocol, and this led to have a very scalable system. Not only in this scenario, we can also add the external service, like, for example, a weather forecast or a passenger information system. As well, the operator workstation that are inside the control center. And on the top, you will have the application framework where there are the traffic management service. For example, the applications that are managing the interlocking or the RBC. So the next slide. The core of this system is this integration layer. That's in the case of the Optima project has been implemented by using RTI DDS, which is a commercial variant of OpenDDS protocol. And in the Optima, we have just added the integration layer API that integrate, next slide please, that integrate the Optima requirements and can connect in a seamless way the existing signaling infrastructure and enable the access to the external application. The integration layer APIs has various services that let the various operations to be run in easy way, like authentication, authorization, transaction, and logging service, and so on. And then, next slide. The other core component is the common data model. This model guarantees the interoperability between the different data sources and system application. And it allows the integration of legacy and future application in just one communication structure. The data definition depends on business requirements, and this work has been conducted by UEC in collaboration with X2R4 complementary projects. The outcome is a platform-specific models that is implemented inside the Optima project. If we see in the next slide, yes, from the top left, you see that you start with a requirements that can come from Excel file or UML diagram or XML sheet. And with this, you have the CDN definition that usually define a platform-independent model. This platform-independent model have to be translated in a platform-specific model, specific to the platform you are using, and this is possible with the tools that we are getting from X2R4 project, and the outcome are a protobuf schema that go inside a codec library. This codec library is used by any software service or application, for example, Lice Business Service or application prototypes. And in this way, every application can communicate in a standardized way with the integration layer. So on the integration layer, you have the binary data structured according the CDN definition. And all the operations are coordinated by the integration layer service. Okay, the next one, another things that is important to notice is that how we get the data from the field. In the Optima project, we have 3 different operators, ADIF, RFI, and Sprava Selenix, that is the sex operator. We get the data from their track circuits. The data are collected on the infrastructure manager service. Then here, for regulatory issues, so we cannot be directly connected to them because for cybersecurity reasons. So we cannot get the data in real time, but we get the log files and we anonymize them. And then the data is elaborated from the different level of interface that parses the events coming from the infrastructure manager and play again this event on the integration layer, and so talk with the integration layer through the integration layer interface. If we look at the different at the next slides, one question that could you could wonder is how we deal with the 3 different infrastructure managers. Next slide, please. Because in Optima, we are using the railway lines that start from Ventimiglia and end in Albenga. And in this line, that is the Optima railway network, we have also to map the data coming from ADIF and from SEX Republic. So to do this, we add a further layer of software that is named in Optima one virtual track. So we are, for example, for the weather forecast that is taken from a station in Malaga, in Spain, we map this on this track, and that is done by software. So we are mixing the data coming from different infrastructure manager, just is one track. We do this just to demonstrate the interoperability of different data sources. Okay, the next slide. This is a typical configuration of the operational workstation that where the different applications of the Optima projects are controlled. And for example, here you can see an application about the traffic management. And then in the next slide, I can show you what is the application framework. An application framework is a uniform environment where you can put your application inside virtual machine or containers. So each application is well isolated to the other, and they are in the control of the infrastructure manager. And all these applications use the standardized interfaces that are available on the integration layer. And so they can talk each to the other, and more important, with the field infrastructure in a standardized way. The access to this application is usually possible by the integration layer, but sometimes is also possible through the application framework REST API for some particular case where it's more convenient to use this. Also, the application framework lets a better life cycle to let the vendors to deploy the application inside the infrastructure management environment. In the next slide, we see quickly how this application framework is organized. We have in the data centers several servers with VMware software that lets you to manage different virtual machine and containers. And above here we have all the software that manage the integration layer APIs, the different service about interlocking RBC, maintenance, service, and so on. On the bottom of them, they are accessing to the persistence layer where they hold all the log files. And still inside this environment, we'll have the TMS service that are still contained inside the virtual machine and containers. In the next slide, here you can see an example. On the right side, you see in the black part, on the top you see how the data is got from the legacy TMS. That should be some data about train position. And that is a legacy format that is coming from RFI and is written in Italian, for example, the position, the end, treno, and so on. And this data, of course, is not interoperable at all. Applying the transformation with the platform-specific models, this data is transformed in something that follow the CDM rules and in the JSON file. And here you can see the transformation in the JSON format. And this is shown here statically, but if you click on this slide, this is the continuous flow of an event that we are flowing on the integration layer. So there are thousands of messages that flow on integration layers that depends by the different events that are coming from the different sources. So now we are at the end. We go to the last slide. Currently, the Optima demonstrator is in the final stage of the development, and we should finish this development hopefully in a couple of months, and then we will start the validation activity. This validation activity will be integrated also by the external validation, because the prototypes that are currently developed in X2Rail Shift2Rail project will be connected to Optima integration layer, and so the X2Rail 4 prototypes we use the data coming from the field to the Optima, and they will use more important the same integration layer and their application, so the application of another project, will be interoperable with the data got from the Optima Rail Business Service. And that is possible because there are two key elements. One is the CDM, the Common Data Model, or as Pierre said, the conceptual data model. They are quite the same things. And the other is the integration layer. And if this joint collaboration will be successful, the Optima demonstrator will be the technological demonstrator TD 2.9 of Shift2Rail. This I have finished for this. Thank you to everyone. Thanks.
Thank you. I think we don't have so many time for the question. We are far behind the schedule. So I let Paolo maybe conclude the day. Thank you very much for all the different presentations. It was very, very interesting. And we restart tomorrow at 9:30.
Okay, well, thank you to all of you for the presentations. We would like to invite all the speakers of this afternoon to come to the stage, please, as well as the moderators. You will receive a traditional little gift as a thanks for joining this event. So as thanks for your investment, for taking part of the conferences, you receive a little chocolate box for Christmas. Chocolates made by a little artisan here in Toulouse, very famous. So I hope you will enjoy it. Thanks again for your investment for the ICT. Thanks again also to Paolo for this first day. The organization was complicated maybe, but we managed to do it well. I just would like to remind that this event has been broadcasted live on the YouTube channel, and we had quite a lot of attendees online as well. So thank you to all these people who joined us virtually. Thanks again for the speakers online on the WebEx, and maybe the word for Paolo to conclude this first day of conferences.
Thank you everybody for your participation. I hope now you will enjoy a cocktail dinner which is offered by the organization, and I hope to see all of you tomorrow. Have a nice evening.
Have a nice evening.
Thank you. So little cocktail is out of this conference room, and see you tomorrow morning for the second day.
See you. Bye-bye. Thank you.
With all the complexities of the EU, national and international legislation, funding and advocacy, running a successful company in Europe is complicated. There's an easy way to make sure your company's concerns are being heard. Become a member of UNIFE. Get access, influence, and visibility where it counts. Starting with a direct line to the decision makers creating regulations that shape our industry's future. UNIFE gives you the intel you need to access many funding, research, and partnership opportunities available. We provide you with all the latest information about the rail industry. UNIFE has dozens of committees and working groups to help guide our members through our advocacy strategy and share best practices around a wide range of topics. You'll also get fantastic speaking, networking, and sponsorship opportunities with key partners, potential clients, and decision makers in our sector. With over 100 members, we fight for more business opportunities for European rail manufacturing companies worldwide. Join us at UNIFE.